Last class we have discussed regarding timing control. So when we are going to consider timing control, there we are going to consider mainly three types of timing control. So one is delay based timing control, and the other one is event based timing control. Third one is level based timing control. So when we are going to consider these delay based timing control, there we will going to specify the corresponding expression or delay time. In at that particular time, event will going to occur or the execution will going to occur. And in case of event based time control, we will going to check a particular event occurring on the signal. Like for example, if I am going to take clock signal, whether an positive edge of the clock has occurred or negative edge of the clock has occurred, that we have to test. So that is why it is called as event based occurring time control. And the third one is level based time control. So level based time control means we will be checking level of a particular signal or expression, whether it is continuously high or low. If it is testing for true condition, whenever the true condition is obtained, in that case the corresponding statement will going to execute. This is how we are going to consider level based time control. And after that we are having conditional statement. So in conditional statement, mainly we are having if condition. So why we are going to use conditional statement means we have to check whether some conditions of a variable or expression is true or false. So according to that, here we are going to mention the condition. So whether we have to check whether an equality condition occurs or any relational condition like greater than, less than, all these things. So when we are considering the conditional statement as if statement, there I am going to mention the condition. And mainly there are three ways of writing if statement. That is, either only if I can consider, means if there is only one condition, I can use only if statement. If there are two condition, then I can consider if as well as else. And if there are more conditions, then I can go for if else if condition. Like this we can able to consider the corresponding condition. So first let us consider an example. So here this gives the syntax. When we are need to check only one expression, so here I am going to use if statement. If the corresponding expression is true, in that case whatever the true statement I have mentioned, that will going to execute. Suppose if the corresponding expression is false, then it will not execute this. There is no alternative, but it will not going to execute. This is how we are going to consider if statement. If the condition is true, only the true statements has to execute, otherwise it should not execute. This is how we are considering. And the second type what we are having is when there is a conditional test, that is for true as well as false. When we are considering both the conditions, in that case we will going to use if else statement. In case of if else statement, what happens is here first it will going to check for the true condition. If the true condition is satisfied, then the statement, that is true statement, will be executed. Suppose if the condition is false, then the else part, means the statement present in this part, will be executed. So like this we will going to check for true as well as false conditions using if else statement. Similarly, we are having type 3 condition. Type 3 condition means when there are more conditions has to be tested. In that case, we will going to use nested if else if statement. So nested if else if statement means here we will going to check whether the first condition is true. If the first condition is true, it will execute true statement. Suppose if this condition is false, then it will come for this particular else part. So in this else part, again it will going to check the another if statement is present. So it will going to check the second expression. If this condition is true, it will execute this. Otherwise, for this particular if, this is the else part. So in this else part, one more condition we are going to check. So this is how we are going to consider if else if statement. And if none of these conditions are true, then the last condition means else part, the default statements will be executed. So like this, we are going to consider the conditional statement based on the requirement. Okay, let us consider an example on this. So when we are going to consider an example, so here what I can observe is we are considering if not lock. So in that case, buffer is equal to data. I am using only one statement, that is if not lock is true, means if the value of lock is equal to 0. So in that case, now whatever the data is present in the variable data, that will be copied to buffer. Otherwise, it won't execute. Okay, because I have not mentioned any other condition, so it will not going to execute. Similarly, here what it will do, if the corresponding enable is high, in that case, it will going to assign the value of in to out. Otherwise, it will not going to assign. This is how we are going to consider only if statement. In case of type 2, what we can observe here is I am checking whether the number queued, means this particular variable is less than the maximum depth. This is where we are going to use, means when we are transmitting any data or when we are receiving any data, if the data is very large compared to the buffer size. So there what we have to do, we have to check whether the queue is large or smaller than the expected length or not. If the incoming data is smaller than the expected buffer length, then it will completely receive the data. Otherwise, it will not going to receive. That condition I have to mention. So that is why here we are going to check whether the number underscore queued is less than maximum depth. If this condition is true, it will receive the data and it will give the corresponding queued number. Otherwise, if this condition is false, means if the number q is greater than or equal to the depth, in such case, it will going to display q is full, try again. So that the complete buffer has been completed. So there is no extra memory to save the data. So we can tell that q is full. Okay. If we do not put else part, what happens? If as long as the buffer is having memory, it will download the data and afterwards it will stop. It won't give any intimation. So if I want any particular intimation, then I can place this particular statement in the else part. So like this, we can consider two different conditions, whether the true condition has to satisfy or false condition has to satisfy. And the next one, what we are having is type 3 statement. So in this type 3 statement, what we are doing is, first we will going to check. This example we have considered in the lab, like ALU and all. So there, what we are going to do, or even in priority encoder also, most of the time we have considered this. If one particular condition is not true, then we will be trying the other condition. Like this, when multiple conditions has to be tested, in that case, we are going to use type 3 statement. So in this type 3 statement, here an example of ALU is considered. If the ALU control, it is similar to the opcode. If the opcode is equal to 0, it has to perform addition operation. Otherwise, if the opcode is equal to 1, it has to perform subtraction. Otherwise, If the opcode is 2, it has to perform multiplication. If none of these values are present in the opcode, then it has to display invalid ALU control. And remember one thing here, when we are considering the if statement, suppose if this is the first condition that I am testing, if this is false, it will go for the second part, that is else part. Again, in the else part, I am mentioning the corresponding if statement. And if this particular condition is true, it will execute this the statements that come under the true part of the second if statement. Otherwise, it will go for the else part. So like this, we will be getting multiple conditions. And remember, for this if statement, there is only one else. And again, for this if, there is only one else. So like this, many if statements can be nested inside the another if statement. That is why it is called as nested if statement. Usually while writing C program and all, we are going to consider if else if statement. So there what it will do, first it will going to check one condition. If it is false, it will go for the second condition. And if this is also false, it will go for the third. So like this, this represents only one if statement with multiple conditions. Okay, there is only one if, but here in order to check 4 different condition, I need 4 different if statement. Okay, so that is why for every if statement, there will be only one else part. There will be no multiple else part. This you have to keep in mind. In Verilog, we do not have single if else if statement. Instead of that, we are having nested if statement. Okay, that is used only in type 3 statements. So type 3 means when more than 2 conditions are present. Two conditions means only if else is enough. If more than 2 is present, then I have to go for type 3 statement. Okay, this is regarding conditional statement. And the next one, suppose, yeah, one more thing I forgot. So while mentioning the condition here, this can be either a variable or an expression. While considering the expression, we have discussed different types of operators and logical, bitwise. All these operators we have discussed, arithmetic operators and all, relational operator, equality operator. All those operators can be used to test the condition. So in general, while writing the syntax, we are going to write it as expression. This expression can be a variable or any expressions that we have discussed in data flow modeling. Okay, like this we will going to check. And also we will be always checking for either trueness of the expression or false of the expression. Depending on the requirement, we will be checking whether the expression is true or false. And next one, what we are having is multi-way branching. As I told, when there are multiple conditions, in such case, we will be using type 3 condition statement. That is nothing but if, nested if statement. Apart from that, one more thing what we are having is case statement. So where case statement we are going to use means, for example, if this particular expression is having more than one alternative values, and for every alternative values, different set of statements has to be executed. In such case, we will going to use case statement. Okay, the best example what we can consider is ALU. So in that ALU, we will going to consider case opcode, isn't it? The opcode can take n number of values. If the opcode value is 0, it has to perform, execute some set of expression. Suppose if the opcode value is 1, it has to express another set of expressions. So like this, when there are more number of alternative values for a given expression, then we can use case statement. It is similar to the nested if statement, that is nothing but if else if statement. But here, one more thing we have to remember, when we are going to consider this conditional case statement, only one expression, all different alternatives we are considering. But if there are different types of expression, then I cannot use only one case statement. There I need to use different number of case statements according to the number of expression. Okay, so here in this I have taken the example of ALU. Similarly, when I want to perform any particular logical operations or any operations like multiplexer or encoding operation, so there I'll be taking different case statement. Even though I may write in the same program, that is in the same circuit, I can use multiple sub devices or sub circuits, and for each circuit there may be different expression. According to that, I can use different case statement. So that is why while writing the statement here, for only one expression, many alternatives we will going to mention. But if I consider if else if statement, in the if I can consider any expression. It doesn't mean that only for one expression I have to consider many alternative in if else if. I can use that as well as I can use different expression in the same nested if loop. Okay, this is what we are going to consider multi-way branching. And always remember one thing, either you use if statement or case statement. If the number of statements, executable statements is more than one, we have to use begin as well as end. Okay, suppose let me consider that if the expression is equal to alternative 2. So when the expression is equal to alternative 2, if there are three different expressions, statement 2, statement 4 as well as statement 5, like this, if there are three different expressions, then I have to insert the keyword begin here and I have to insert the keyword end here. So like this we have to consider the corresponding alternatives. Sorry, when more number of statements are there, we have to mention begin as well as end keyword. Then all these statements will be executed. Otherwise, it will going to show error. And while writing case statement, we are going to use three keywords. One is case, end case, and default. Case indicates beginning of the case statement and end case indicates end of the case statement. And when default we are going to use, when none of these alternatives what we are mentioning is not satisfied, then at least one particular set of statement has to execute. In such case, we are going to use default statement. Okay, let us have an example of this. So here, yeah, in this case, we have considered how ALU will be controlled. So in this ALU control, we are considering the corresponding values of ALU as 0, 1, 2, 3, like this. There are 4 bits, four different condition, because we have considered 1 down to 0 means only 2 bit. 2 bit means I can express 4 conditions like 0, 0, 0, 1, 1, 0, 1, 1, isn't it? So accordingly, here I have mentioned 3 different statements, that is x plus z, x minus z, and similarly x into z. So like this I am using 3 different statements. If none of these alternatives are true, then suppose if the input, instead of it is equal to 1 1 or 0 0, if it is equal to 1x, let me consider my input is equal to 1x. I have not mentioned this condition. I have mentioned only 0 1 2. And what about the output I should get for the inputs like 1x or if both the bits of the ALU are equal to Z. In that case, what should be the corresponding output? So for that, I am using the default statement. It should be present at the last, and here it will going to check by default. If we do not mention any valid opcode, in that case it has to mention invalid ALU control signal, so that user or designer will come to know whether the value is given or not. If it is given, then either any of these statement has to execute. If it is not given, in that case it has to indicate like this. Okay, this is how we are going to consider multi-way branching, and it is similar to type 3 condition because more alternatives we are going to mention. Okay, this is one of the example while writing the type 3 conditional statement. And one more thing we have to consider while mentioning the order of the values in the alternative. That is, here first I have mentioned whether ALU control is equal to 0, and then I have mentioned 1. So in the same order it will going to check. First it will read the value of ALU control, and then it will compare with 0. If the ALU control value is equal to 0, then this statement will execute. Otherwise it will compare with this. So one after the other alternatives it will compare, and finally if none of the alternative is matched, then by default it will going to execute this statement. If you reverse the order, again you may get different type of output. This you can observe in a priority encoder. Okay, we have taken a priority encoder example in the lab. So there we had mentioned the order. First I have mentioned the order. Even though I am giving highest priority for the MSB, first I am checking the value as initially whether I will going to check whether all the upper bits are 0 and the last bit is equal to 1. If this condition is true, my output should be equal to 0 0 0. That is 8:3 priority encoder. And similarly what I have done is I have taken 1 and all the lower bits as X. So what it indicates that when the MSB bit is I, so whatever may be the other bits, the output should be equal to 10111, isn't it? So this is how I had given the program in priority encoder. If we place in this order, suppose if the input given is like 1100 or 1x or x00 like this, in that case we will get different output. And if I reverse the order, I am not changing, that is I am giving preference for MSB only, but first I am mentioning this condition, and at the last if I mention this condition, I will be getting different output. This you can observe by executing program, and then you can understand how we will going to get different values if we change the order of alternatives. Okay, this is how we are going to consider case statement. And one more example what we are having is, see, in the previous example I have taken only a variable, that is ALU underscore control. But next I'll take an example of that is concatenation. So here for a multiplexer, that is 4:1 multiplexer, I need 2 select lines and then 4 corresponding inputs and then 1 output. So here when I'm using case statement, I need to check whether the input is 0 0 0 1 1 0 or 1 1. So in such case, instead of using that is nested case statement, I'm going to concatenate these two. When I concatenate these two, what happens? Always MSB bit will be S1 and LSB bit will be S0. So this concatenated 2 bit will be compared with 0. If it is equal to 2 bit 0, out will be equal to the first input I0. Suppose if the concatenated bit is equal to 1, in that case output will be equal to I1. So like this, we are going to get the output. Means I can even place expression over here. It doesn't mean that I need to place only variable. If the number of variables are more, then instead of using multiple case statement or nested case statement. Nested case statement means inside one case statement, another placing another case statement. So here in this example only, if I want to consider, that is the same multiplexer, I can write it as, say, multiplexer program can be written like this, that is case, inside this parenthesis I'll give S1, and then I'm going to mention one tick D0 or one tick D0. Okay, so if the first bit is 0, then I need to check whether S0 is 1 or 0. So for that, once again I can use case. Here I can check S0, and then I can mention alternative for this case, that is when S0 is equal to 0, in that case out should be equal to I0. Okay. Otherwise, if the corresponding input S0 is equal to 1, so in that case I need to mention, if the corresponding bit is 1, then out should be equal to I1. So like this, we are going to consider nested case, and afterwards I am going to mention end case. Okay, so what it indicates, inside this particular alternative, we are writing one more case statement. This is known as nested case statement. So either we can write like this, or else we can able to write like this by using a concatenation operation. So like this, we can able to write multi-way branching by using expression. Okay, and one more thing, let us consider, that is, here in the case statement, use of default is optional. If we want, we can use. If we do not want, we can skip. It will not going to show error, but it will simulate, but while synthesizing we will be getting the error. Why we are going to get error means, here we have mentioned the possible conditions like 0, 1, 2, 3, and as we know that apart from 0 and 1, we are also having a bit can be represented as X as well as Z, isn't it? When these condition occurs, what should be the output? Or else if a combination of 0 and X occurs, so in that case what should be the output? If I miss default part, in that case it will only check these 4 conditions and it will come out. Okay, for us it is easy to understand because only 4 conditions has to be checked, and for remaining condition it is not required. But while making the circuit, we have to consider all possible inputs, right? So that is why if this is the input, I have to mention what should be the output of a circuit. So that is why if I use default statement, it will come to know what it has to do. Means it indicates that I have addressed all sort of input condition, not only in case statement, even in if statement also. If I mention only for true conditions, like as I told, if I am going to consider if A, so if A means if the value of A is greater than 0, then it will be true condition. In that case, I am going to mention Y is equal to X. So whenever A is equal to true, the value of X will be copied to Y. But what happens when A is false? Or what happens when A is unknown? That I have not mentioned. So when I have not mentioning, then it will be ambiguous for the circuit. Okay, what it has to do. So in such case, we may get error when I consider the practical circuit. Means the CAD tool cannot give one particular solution. We have to mention whatever the circuit condition we are going to mention, according to that it has to design. That is why while writing a program, we should take care that we have addressed all possible input conditions. In that case only we can get a correct circuit. Otherwise, we will not going to get a correct circuit. So that is why we are going to use default. Okay, this is one of the advantage of using default. And similarly, we are going to use else in the if statement. So when I mention else, so in this else part, I'm indicating that if only A is true, this has to execute. Else, I'll be executing some other statement. Okay. And one more thing we have to remember, if I do not want to execute any other statement, means if the condition is true, it has to execute. Otherwise, it should do nothing. So I have to indicate for the cat tool that it should not do any operation when the condition is false. So how to mention that? To mention that, we are just going to use the keyword begin and end. Okay. So between this begin and end, I'm not going to write any executable statement. So when I'm not going to write any executable statement, it indicates for the cat tool that it should not do anything for the alternative else. Only it has to execute when A is true. Otherwise, it should do nothing. This indicates that I have addressed all possible values of A. Because when A is equal to X or when A is equal to Z, in that case, I am clearly indicating do nothing. Okay. So if I do not mention this, then it will be ambiguous for the cat tool. What it has to do when the condition is false. So to remove all these things, we have to address all possible types of input. Till now, you have seen only how to write the program and how to check whether your program will going to work properly or not using simulation. But when we are considering the practical circuit, we have to convert this particular program into circuit by doing synthesis. So while generating the circuit, it will show error. Even though logically your program may be correct, you will be getting correct output, but your circuit cannot be finalized. Why it cannot be constructed means I have not mentioned all possible types of input. So that is why there while implementing I will get error. This you have to take care while using behavioral level of abstraction, because in data flow as well as in gate level we are mentioning the entire condition, that is entire circuit we are mentioning in gate level, and in data flow entire operation we are mentioning. There we are not mentioning any particular condition, but here in case of behavioral we have to mention a particular condition. Means all possible input conditions has to be taken care. And the next one what we are having is when the inputs are having the value X as well as Z. In such case, how to write the corresponding statement, case statement, that we are going to consider in this example. So here I have taken the example of demultiplexer. In this demultiplexer, we are checking for the if the values of S1 and S2 are either 0, 0, 0, 1, 1, 0, 1, 1. I am mentioning the first output, out 0 will be assigned the input and other outputs will not be connected, that is disconnected. So I am mentioning it as Z. And here you can observe that since there are 4 different statements, out 0, out 1, out 2 and out 3, I am using the keyword begin and end. Okay. When there are more statements, we are going to use begin and end. And one more thing here, I am mentioning account of unknown signals means apart from those two conditions, either 0, 0, 0, 1, 1, 0, 1, 1, if these are the possible conditions, execute. Okay, in such case, what should be the corresponding output? So for that, see here, you can observe that more than one condition I am mentioning because I need to execute same set of statements for all the above conditions. So in such case, I can separate the conditions using comma. Okay, whenever I'm having more than one alternatives with same set of output, I have to separate it by comma, or else I need to write the statement those many number of times. See, for example, here in this, for only one condition, I have written this set of statement. Similarly, when the input is equal to x0, my output should be equal to x. Okay, and even when the input is x1, then also output should be equal to xx. So writing it separately, I can combine those conditions by separating comma before the semicolon symbol, and then I can write, so that a common execution will be taken care for all these alternatives. Similarly, for these alternatives, a common thing can be considered. Apart from this, if any combination of the input is left out, then I will display unspecified control signal. Okay, this is how we can able to consider the case statement. So until now we have discussed regarding if statement as well as case statement, and also we should know we have to address all possible input combination because this is a behavioral level of architecture. So I have to tell how the circuit has to behave for a given particular input. So I need to address all possible inputs. Okay, this is regarding case statement. And then last one, what we are having is case X and case Z. So when we are considering X as well as Z in the input, instead of using only case statement, we may not get the proper output. So that is why we are going to use case X and case Z statement. Here in the input, if any of the bit is equal to high impedance or if it is equal to unknown, in that case, for all these things, my it will treat those values as don't cares. So when these values are treated as don't cares, then this example we have considered in priority encoder. We have used case X and case Z, isn't it? So while writing the priority encoder, if I use only case statement, then it will not going to give proper output if any one or more bits are unknown on high impedance. But if I use case X or case Z, then it will going to consider those values also. And wherever Z is there, it will be treated as don't care. And when we are having case X statement, if the input is X, in that case, either it can take the value 0 or 1. So like this, according to the requirement, it will take the priority and it will going to give the proper output. So that like how we are having case statement, we are also having case X and case Z. This is a simple example like encoder. In the lab, we have done 8:3 encoder, and this is an example for 4:2 encoder. Here you can observe, and let me know what output we are going to get for this particular statement. Here, what I have mentioned, if the MSB bit is 1, in that case, the next state should be equal to 3. Suppose if the MSB bit is don't care and this bit is 1. So in that case, the next state should be equal to 2. So here I have used don't care. Don't care can take the value of either 0 or 1. So I want you people to take this as an assignment. for coming for the lab, and then you have to check what output you are going to get for this particular program. Whether you are going to get the same output, or else for all these conditions you will be getting only 3 as the output. That I want you people to execute and verify. Okay.